Computers are an indispensable asset to the 21st century lifestyle. But how exactly did the computer blossom to the way it is today? Exploring new technologies, the rise of the computer. During World War II, Americans did mathematical procedures to try to crack German codes. To speed up the computations, many believed a machine could take on these lengthy procedures. J. Presper Eckert and John Mauchly began creating the Electronic Numerical Integrator and Computer, better known as ENIAC. The ENIAC was huge. The ENIAC weighed an astounding 30 tons and measured 100 feet long. The ENIAC's power is equivalent to today's version of a battery watch. A vacuum tube had a specific purpose and did one function of the computing, such as an addition or multiplication. ENIAC contained 19,000 of these tubes. In this interview by the Computer Museum, J. Presper Eckert describes what it was like to create the ENIAC.
The reason I thought of this is that I said, well, if we ever build another one of these machines, and when we don't just have the ballistics problems and the internal ballistics problem and a few specialized problems that we knew about to do, how do we decide how many plugs to put over here for programming, how many counters or flip-flops or something to put in the memory, how many switches to put over here with resistors, because that's going to be different for each class of problems. There are some narrow classes where it's pretty much the same, and those are the ones we were catering to in this machine. But how do I do it when the problems are wildly different? Well, I said, I've got to find a way of generalizing this. I said, everything in science that ever amounted to anything was because somebody figured out a way of taking some specific problem and generalizing it. So that what I said was that we need a memory device that's cheap enough that we can use the memory device for everything. Normally, to start the machine, one pressed this button here, and that turned on the heaters of the machine. And it also turned on the DC voltages. Now, we could also turn the DC voltages off and have only the heaters on, which we frequently did during testing, because turning the heaters off and on due to thermal expansion in the tubes frequently blew a tube. In fact, if you turned the machine off and on once, you could almost count on it having one blown tube, where otherwise the machine would go for 1 or 2 days at a time without a blown tube. This button over here is the initiating switch. This is the button that gave you the first pulse that started the program into operation.
Many recognized a computing machine could rapidly increase the speed of computation for important operations. However, ENIAC's very small source of memory and outrageous time-consuming operations wouldn't cut it.
The ENIAC project concluded with the design and eventual construction of EDVAC. The draft EDVAC report by John von Neumann is the seminal description of the first stored program computer.
The EDVAC stands for Electronic Discrete Variable Automatic Computer. This was the first computer to have a stored program concept. The stored program concept, created by von Neumann, is the basic guideline of the processors that are used in computers today. The stored program concept consisted of 5 basic units: the central control, the input and the output, the memory, and the central arithmetic. Shortly after the creation of EDVAC, the Universal Automatic Computer, or UNIVAC, was created by J. Presper Eckert and John Mauchly, the former creators of ENIAC. These two exchanged ideas, and soon the UNIVAC was finished construction in 1951. The UNIVAC was the first computer to be sold commercially. One UNIVAC cost around $1 million. Today, a UNIVAC would have sold around $9 billion. The UNIVAC, using its multi-purpose technologies, correctly predicted the result of the 1952 presidential election. The UNIVAC, despite experts saying the presidential race was very close, predicted Dwight D. Eisenhower to win by a landslide. CBS broadcast the UNIVAC's results. Here's an advertisement for the UNIVAC.
This is weather, one of nature's ever-changing mysteries. It affects every one of us every day of our lives, and yet we know relatively little about it. Weather, that's something we'd all like to do something about, isn't it? And so tonight we've brought you down here to Remington Rand's New York Computing Center in order that we might show you that something actually is being done about it. The hero of our story tonight is the giant electronic brain developed by Remington Rand, UNIVAC. Now, recent experiments show that future use of UNIVAC may give us faster and more accurate weather predictions than were ever possible before. You see, UNIVAC can take the past histories of thousands and thousands of storms, analyze them, compare them with developing conditions, and make predictions, all in a matter of minutes. Calculations that would ordinarily take hundreds of man-hours to complete. Data the memory tanks make immediately available 12,000 additional units of information. And all of this complex weather data is analyzed in the heart of the UNIVAC, the electronic central computer, capable of making over 2,000 mathematical calculations per second. Now, here is where we get the answers. You might call it the voice of UNIVAC. Actually, it's a high-speed printer that prints results at the rate of 600 lines a minute. So you can see that UNIVAC is both fast and versatile. But most important is the assurance that UNIVAC will give you the right answer. And that's made possible by UNIVAC's unique ability to check itself on possible errors. Let's watch right now as UNIVAC puts itself through one of these self-examinations. Here it is checking on some of its own units. It's really an amazing system, isn't it? Amazing and yet so wonderfully practical.
The UNIVAC motivated other companies to create smaller, more general-purpose computers. In 1956, the Libroscope LGP30 was introduced. This small, innovative design cost around $50,000, a convenient price compared to the UNIVAC's $1 million. Many companies bought computers to be more efficient with their work. In 1973, Intel created the first microprocessor, the Intel 4004. This was a breakthrough in computer history. Not only did the microprocessor make computers easier to store, it decreased the price of computers as well. Shortly after the invention of the microprocessor, the Altair 8800 was invented and cost $621. The UNIVAC was 1,610 times more expensive than the Altair 8800. In 1977, Steve Wozniak and Steve Jobs made an exchange that was revolutionary. They began the Apple Company. Soon, they released Apple II computer. Similar to that of the Altair 8800, the Apple II featured a convenient size and a somewhat affordable price at $1,200. Apple sold an astounding 2 million units worth of Apple II, partly because of its innovations such as the point-and-click technology. The computer has made marvelous leaps over the past half-century. From the 30-ton ENIAC to lightweight cell phones, the computer has made remarkable changes to our daily lives.
I think we've got a wonderful story. The evolution of computing has been a great thing, and I happen to believe that the computer is the greatest invention ever.